In October 2025, a paper published in the journal Nature quietly ended one of paleontology's longest and most bitter arguments. For nearly 40 years, scientists had assumed a certain kind of small Tyrannosaur skeleton, mounted in museum halls beside towering adult T-Rex skeletons, was simply a teenager, a young T-Rex not yet grown into the monster everyone recognizes. But the new study said something very different. Researchers had spent 2 years studying a fossil now known as the dueling dinosaurs, a triceratops and a smaller tyrannosaur locked together in what looks like a final fight to the death, their bones still tangled exactly as they died. When the team counted the growth rings inside the bone under a microscope and checked how fused the spine had become, they found an animal that was 20 years old and fully grown. It was never a baby T-Rex. It was something else entirely. That means for decades, the studies that used this exact kind of fossil to model how T-Rex grew up, how it hunted, how it behaved as a young animal, were quietly built on the wrong dinosaur. And the dueling dinosaurs fossil isn't some obscure specimen dug up last year. It's been sitting, mostly hidden from science, since 2006. A rancher found it on his land in the Badlands of Montana. For the next 14 years, nobody outside a small circle of scientists got to study it properly, because the fossil itself was tied up in a legal fight over who actually owned it, locked away from researchers while lawyers argued in courtrooms. It only went on public display in 2024, unveiled at a museum in North Carolina, which means this isn't ancient history. This is one of the most famous predators on Earth, and scientists were still fighting over what it even was, right up until a year ago. And it turns out, Nanotyrannus isn't the only argument still going, because once you start looking, you find the same thing over and over. The dinosaurs you think you know best, the ones on the posters and the lunchboxes and the museum banners, are the exact ones scientists are still quietly at war over, 3 of them in particular. And by the end of this, the confident little facts you learned as a kid are going to look a lot shakier than they did 5 minutes ago. Let's start with the one that just blew up. The small tyrannosaur in the dueling dinosaurs fossil has a name that's been causing fights since the 1980s. Nanotyrannus. It means, roughly, dwarf tyrant. And for as long as that name has existed, paleontologists have split into 2 camps over whether the animal it describes is even real. Here's where the argument came from. Back in the 1940s, a small tyrannosaur skull was pulled out of the same rock formation that produces Tyrannosaurus rex, the Hell Creek Formation. It was clearly a tyrannosaur, but it was small, and it had features that didn't quite line up with a fully grown Tyrannosaurus rex. For a while, some researchers thought it deserved its own name. Then, the tide turned. Through the following decades, most paleontologists decided the simpler answer was the right one. It wasn't a separate species at all. It was just a young Tyrannosaurus rex, caught partway through growing up. That became the mainstream view. Small tyrannosaur from Hell Creek? Not a new species, just a kid. Case closed. And for years, that's how these fossils were treated. The idea that Nanotyrannus might be its own animal didn't disappear entirely, but it got pushed to the edges, argued about at conferences, rather than settled in the literature. If you were a young paleontologist and you wanted to be taken seriously, the safe position was that Nanotyrannus wasn't real. The problem was, nobody had the right fossil to settle it. To prove whether a small tyrannosaur was a baby or an adult, you need to look inside its bones, and you need a specimen complete enough to trust what you're seeing. Most of the fossils in the argument were partial, fragments, a skull here, some limb bones there. You can argue about a skull for decades because a skull alone doesn't tell you how old the animal was when it died. And that was the whole fight. Was this a small adult or a large child? Without the rest of the skeleton, both sides could keep believing what they already believed. The dueling dinosaurs changed that, because the small Tyrannosaur in that fossil is not a fragment. It's one of the most complete Tyrannosaur skeletons ever found, close to whole, tail and all, preserved down to fine detail, with skin impressions and possibly even traces of soft tissue, and locked in the ground next to a Triceratops in a way that suggests the two animals may have died together in a real encounter. This was the specimen the argument had been waiting for the better part of a century. For once, nobody had to guess at the missing pieces, because the pieces weren't missing. When Lindsay Zano and James Napoli sat down to study it, they weren't trying to reignite an old fight. They were expecting, more or less, to confirm the mainstream view. But, almost immediately, things didn't add up. The arms were the first red flag. In a growing animal, body proportions shift in predictable ways as it matures. But the forelimbs on this specimen were larger and more developed than a teenage tyrant should have had, relative to the rest of the body. That's not how growth is supposed to work. If this were a growing juvenile, its arms were pointing in the wrong direction. Then came the deeper look. The team cut into the bones and read the growth rings, the same way you'd read rings in a tree to count its age. Every year of life leaves a mark inside the bone, and those marks were bunched tightly together near the outer edge, which is what happens when an animal has stopped growing. The rings told them this animal was around 20 years old, and the spine had fused in the places that fuse only when an animal reaches skeletal maturity. This was not a teenager still growing towards some bigger adult form. This was a fully grown adult at its final adult size, and its final adult size was a fraction of a T-Rex. A full-grown T-Rex could push past 40 feet and weigh several tons. This animal, done growing at 20 years old, would have stood beside it like a different creature entirely, because that is exactly what it was. And that detail matters, because it flips the whole picture of the world these animals lived in. If Nanotyrannus is real, then the last stretch of the age of dinosaurs wasn't ruled by one giant predator with a slower, smaller teenage phase. It had at least two separate hunters sharing the same ground, the heavyweight and the sprinter, the crusher and the chaser. The final million years before the asteroid were more crowded and more competitive than the single king story ever allowed. To make sure they weren't fooling themselves, the team compared this skeleton against more than 200 Tyrannosaur fossils, and the differences held up across the board. More teeth than T-Rex, fewer vertebrae in the tail, different nerve and sinus patterns inside the skull. These aren't the kind of differences you grow out of. A T-Rex doesn't lose teeth or change the wiring of its skull as it ages. They're the kind of differences that separate one species from another. The conclusion landed in Nature in October 2025. Nanotyrannus was real. It was its own animal, living right alongside T-Rex in the final million years before the asteroid, a leaner, faster predator sharing the same world as the king. Not a stage in T-Rex's life, a rival on its turf. And then the study went one step further, in a way that turned a single reveal into something bigger. While comparing all those fossils, the team found another specimen, one that had also been filed away as a teenage T-Rex, that didn't match either. It was different enough to be its own thing. So they named a second brand new species, Nanotyrannus letheus. The name references the river Lethe from Greek mythology, the river of forgetting, a nod to how this animal had hidden in plain sight, mislabeled and overlooked for decades. Two new predators, pulled out of a pile of fossils everyone thought they'd already identified. Sit with what that means for a second. For years, When paleontologists wanted to understand how T-Rex grew from a hatchling into an adult, they reached for these small skeletons and used them as the early chapters of the story. How fast T-Rex grew, how its hunting changed as it aged, how its body reshaped itself over time. A whole body of research built on the assumption that these little tyrannosaurs were young T-Rex. But if they were never T-Rex at all, then those studies were splicing two completely different animals into one imaginary life story. The teenage phase of T-Rex that scientists thought they understood may have been, in part, a different species entirely. Picture writing someone's biography, and halfway through you realize the childhood photos belong to a stranger. That's roughly what happened to the most studied dinosaur on Earth. That's not a small correction. That's a chunk of what we thought we knew about T-Rex quietly coming apart. And it only happened because one unusually complete fossil finally sat on the right lab table more than a decade after it came out of the ground. Now, if this were the only example, you could call it a fluke, a rare case where the evidence took a long time to show up. But it isn't the only example, because while the Nanotyrannus fight was finally ending, another argument about an even more famous dinosaur was still very much alive. And this one, you can walk into a museum and see for yourself, mounted in a pose that scientists now say is impossible. If you're finding this as fascinating as I do, take a second to subscribe. I dig into the fossils museums argue about every single week, and there's a lot more where this came from. Now let's talk about the strangest large predator that ever lived, Spinosaurus. For a lot of people, the whole idea of Spinosaurus starts with one movie moment. In 2001, in Jurassic Park 3, a Spinosaurus fought a T-Rex on screen and won, snapping the king's neck in front of a generation of kids. Overnight, Spinosaurus went from an obscure name to the dinosaur that beat T-Rex, and museums leaned into it. Across Chicago, London, and Washington, institutions built towering Spinosaurus displays, posed upright and striding forward, jaws open, the ultimate land predator, bigger and meaner than T-Rex. There was just one problem. Almost nobody actually knew what Spinosaurus looked like, because the story of this animal is, in a way, even stranger than the story of Nanotyrannus. It's a story about a fossil that was destroyed. The first good Spinosaurus bones were dug up in Egypt in 1912 and described by a German paleontologist named Ernst Stromer. He published his reconstruction in 1915. A giant predator, nearly 50 feet long, with a sail on its back taller than a person. The bones ended up in a museum in Munich, the pride of German paleontology, studied and admired for decades. And then, in April 1944, during the Second World War, Allied bombs hit Munich, and the museum burned. Stromer's Spinosaurus was destroyed. Every original bone gone. All that survived were his drawings, some black and white photographs, and a handful of measurements. No casts, no backups. The single best evidence of what this animal actually was went up in one night, and it has never been recovered because it no longer exists to recover. So, for nearly 70 years, the world's picture of Spinosaurus was built out of almost nothing. A few sketches of an animal nobody could examine anymore, with all the missing pieces filled in by guesswork. And when museums built their big dramatic mounts, they filled the gaps the easy way by scaling up bones from better-known predators like T-Rex and posing the whole thing like a giant upright meat-eater. It looked confident. It looked settled. But underneath, it was a guess standing on a destroyed skeleton. Every dramatic Spinosaurus you've ever seen in a movie, or a museum, traces back to a few pages of paper that survived a fire. Then, in 2014, new bones came out of the Moroccan desert, and the guess started to fall apart. A team led by Nizar Ibrahim uncovered Spinosaurus fossils unlike anything expected. The bones were dense, unusually thick and solid, without the lightweight, air-filled spaces you see in the bones of fast land predators. When they scanned them, the density readings put Spinosaurus in the same territory as hippos and penguins, animals built to sink into water and stay there, not to sprint across dry ground. The rest of the body told the same story. The nostrils sat high up on the snout, like a crocodile's, good for breathing, while the rest of the head stayed underwater. The hind legs were startlingly short and squat, far too small to comfortably carry a 7-ton animal upright across land. Based on the center of mass Ibrahim's team calculated, the animal looked front-heavy, so front-heavy that walking on 2 legs like a normal predator may not have worked at all. Their reconstruction showed something that had never been seen in a big predatory dinosaur, a Spinosaurus that walked on all 4s and spent its life in the water. This was a direct hit on the museum image. The towering, upright land monster wasn't just slightly off. It might have been fundamentally wrong about how the animal stood, moved, and lived, and it put every one of those expensive museum mounts on notice. And then, in 2020, the same team came back from Morocco with the piece that turned a disagreement into a firestorm, a tail, a nearly complete Spinosaurus tail, over 15 feet long, and it looked like nothing else in the predator world. Instead of the stiff, tapering rod that anchors a T-Rex, this tail flared out into a tall, flexible paddle with blade-like spines running along it. The team didn't just look at it and guess. They built a scale model of the tail, attached it to a robotic rig, and swung it through water to measure how much thrust it produced. Then they compared that number against the tails of other animals. The Spinosaurus paddle reached up to about 75% of the swimming efficiency of a crocodile's tail, and left the tails of other predatory dinosaurs far behind. To them, this sealed it. Spinosaurus wasn't a land animal that waded in now and then. It was an active swimmer, a river hunter propelling itself through the water after fish. For a moment, it looked like the argument was over, just flipped completely around. The land predator was dead. The swimming dinosaur had won. Except that's not what happened, because in 2022, another group of scientists pushed back hard. This team, including researchers who had studied dinosaur biomechanics for years, ran their own analysis of how Spinosaurus would actually behave in water. And their answer was that the swimming dinosaur model didn't hold up. Their modeling suggested Spinosaurus was too buoyant and too unstable to dive and chase prey underwater, the way the 2020 study described. The dense bones were real, but the body also held enough air that the whole animal would want to float, and a floating top-heavy predator can't dive like a crocodile. It would bob and tip rather than knife through the water. Their alternative was a compromise, but a pointed one. Spinosaurus, they argued, was a wader, an animal that stood in shallow water and snatched fish from the surface, the way a heron does, rather than a full-blown underwater pursuit predator. Water, yes. Deep-diving river hunter, no. And here's the part that matters for our story. That argument never got resolved. Both camps kept publishing. Both had real evidence, real modeling, real fossils behind them. The question of how the most bizarre large predator in history actually moved, whether it swam or waded, whether it dove or just dipped, is genuinely still open. As recently as last year, new papers were still going back and forth. Scientists have not agreed. Meanwhile, walk into some of the biggest museums in the world today, and what do you see? In many halls, Spinosaurus is still standing tall, posed upright, frozen in exactly the land predator prowl that the last decade of research has been steadily tearing down. Not because the curators don't know. They do. It's because these mounts are enormous, welded to steel armatures and anchored into the floor with concrete, and tearing one down and rebuilding it means another massive, expensive project, sometimes over $1 million. So, in a lot of cases, the skeleton stays where it is, telling the old story, while the new science plays quietly on a small screen next to it. And here's the quietly damning part. Studies of how people actually move through museums show that most visitors spend less than a minute at any given skeleton, and only a small fraction stop to read a digital label or tap a touchscreen. So the towering upright pose is the version almost everyone walks away with. The correction, the swimming animation on the little screen, barely registers. The myth is 15 feet tall and bolted to the floor. The truth is, a caption most people never read. The gap between what scientists know and what the public sees isn't closing. In some places, it's growing. So that's two of the most famous predators on Earth, both still tangled in live arguments. One finally settled after 40 years, one still unsettled right now. Which brings us to the third. And this one isn't about how a dinosaur looked or moved, it's about its name. Specifically, it's about the fact that the most famous dinosaur name in the entire world, Tyrannosaurus rex, might technically be the wrong one. To understand how that happened, you have to go back to a feud. In the late 1800s, American paleontology was ruled by two men who hated each other, Edward Drinker Cope and Othniel Charles Marsh. They had started as friends, and it curdled into something poisonous, a personal war fought with fossils. Their rivalry was so intense, so vicious, that it has its own name in history. The Bone Wars. They raced each other across the American West, bribing each other's crews, wrecking dig sites so the other man couldn't have them, and naming as many new dinosaurs as fast as they could, sometimes sloppily, sometimes off tiny scraps of bone, just to plant a flag before the other one did. Speed mattered more than care, and that recklessness is where our story turns. In 1892, in the middle of all this, Cope found two partial vertebrae, just two pieces of backbone. He studied them quickly, decided they came from some large horned triceratops-like animal, and gave them a name, Manospondylus gigas, which roughly means giant porous vertebra. Then he moved on to the next find, and those two bones were more or less forgotten for over 100 years. 13 years later, in 1905, a different paleontologist named Henry Fairfield Osborn described a spectacular new predator from a much better skeleton. He gave it a name that would become the most famous dinosaur name ever coined, Tyrannosaurus rex, the tyrant lizard king. Neither man realized at the time that they had named the same animal twice. But there's a rule in scientific naming, and it's a strict one. It's called priority. When it turns out two names have been given to the same species, the older name is supposed to win. It doesn't matter which one is more famous or sounds better or is easier to say. Whoever published first gets the name. And Cope published Manospondylus gigas in 1892. Osborn published Tyrannosaurus rex in 1905. Cope was 13 years earlier. For most of the 20th century, this stayed a footnote because nobody could be sure Cope's two vertebrae really belonged to a T-Rex. Osborn himself suspected the connection as early as 1917, but the material was so fragmentary, and one of the two original bones had already gone missing, that he couldn't prove it. So the older name sat there, indeterminate, unable to make its claim, a loaded gun nobody could quite fire. Then, in June 2000, a team from the Black Hills Institute went looking for the original site where Cope's bones had come from in South Dakota. And they found it, They excavated the locality, pulled out more of the same animal, and confirmed what Osborn had suspected almost a century earlier. Manospondylus gigas and Tyrannosaurus rex were the same dinosaur, which meant, by the strict letter of the priority rule, the correct name for the most famous predator in history should technically have been Manospondylus gigas. The tyrant king, on paper, should have been dethroned by two forgotten vertebrae named during a grudge match in 1892. So, why is it still called T-Rex? Because the naming rules have an escape hatch, and this is exactly the kind of case it was built for. If an older name has essentially gone unused for a long stretch, while a newer name has become deeply established, the system allows the famous name to stand. It's a deliberate release valve, there to stop pedantic technicalities from overturning names the whole world already uses. And by the year 2000, Tyrannosaurus rex wasn't just established. It was one of the most recognized scientific names on the planet, printed in thousands of papers, plastered across movies and museums and merchandise for a century. Manospondylus gigas, by contrast, had barely been spoken aloud since Cope scribbled it down. There was no real contest. The famous name stayed. But sit with how close it came. The name every single person on Earth knows, the one that means dinosaur more than any other word, survived on a technicality. Strip away that loophole, and a British rock band, a movie monster, 100 years of childhood wonder, would all have been attached to a clumsy Latin phrase meaning giant porous vertebra. T-Rex is the name that stuck. It was very nearly not the name at all. A worn piece of backbone, catalogued in a hurry during a feud, almost took the crown. And that's the thread running through all three of these stories. We treat dinosaurs like settled facts, like the arguing is over, and all that's left is the memorizing. A small tyrant skeleton is just a growing one. Spinosaurus is the big predator that beat him. Tyrannosaurus rex has always been Tyrannosaurus rex. Simple, finished. But none of it was finished. One of those facts collapsed in a lab in 2025 when a fully grown Nanotyrannus turned out to have been hiding inside a pile of fossils everyone had mislabeled. One is still being fought over in scientific journals right now, while the outdated version towers over museum visitors who don't know any better. And one only survived at all because of a loophole in a rulebook, a technicality standing between the most famous name in natural history and two forgotten bones. The dinosaurs haven't changed in 66 million years. What keeps changing is us, what we've found, what we've destroyed, what we've argued about, and what we've been quietly wrong about the whole time. So the next time you're standing in a museum, looking up at some enormous skeleton with a confident little label bolted to the base, it's worth asking the question the scientists themselves are still asking. How much of this is settled, and how much of it is just the version of the story we haven't overturned yet? Because if the last few years have shown us anything, it's that the bones are still keeping secrets. And every so often, one of them speaks up and rewrites a story we were sure we already knew.